Evidence number 3, abundant fission tracks. Now, what on earth are these? Well, let me explain. Again, let's go to the bottom of the Grand Canyon. And one of the limestones down the bottom of the Grand Canyon, inside it, there's a little volcanic ash bed from a volcanic eruption. And inside this volcanic ash bed, which is, you can see there where the pen is for scale, it's only about 2 to 3 inches thick. This volcanic ash bed contains zircon crystals, these zirconium silicate crystals that contain uranium atoms. Now, sometimes a uranium atom, instead of decaying, well, as I said, it's unstable and it decays by radioactive decay, okay? And what it does is it ejects just a couple of little particles, and the nucleus just gets a little bit smaller. But on other occasions, we have what is known as fission. That is, instead of a little bit of the of the nucleus coming off, the nucleus splits in half. This is the basis of the atomic bomb. It's called nuclear fission. The atom itself splits in half. So you get 2 fragments or 2 new atoms of similar size rather than something very large, still similar to the size of a uranium atom. So what happens? As the atom splits, the 2 halves fly apart, the 2 small atoms. And this process is called fission. Fission is division. Okay, so what happens? The atom splits apart and it breaks into 2 new atoms. What happens, therefore, inside a zircon crystal is that those 2 atoms flying apart damage the crystal and form a visible damage trail or track, which is called a fission track. And you can actually study these under a microscope. Here's some photographs. You can actually see where the atoms have split apart and damaged the zircon crystals. Now, the more atoms that have split apart, the more of these tracks are produced. So if you know the rate at which this fission or fission process occurs, you can count the number of tracks and use it as an age calculating method. And so this is something you can physically observe. In other words, nuclear decay has occurred through geologic time. There's no question about it. We have physical evidence that there has been abundant nuclear decay. Well, we again look at 3 examples. In the Peach Springs volcanic rock unit near Kingman, Arizona, we find fission tracks equivalent to 21 million years worth of nuclear decay at today's rate of fission. This is at the top of the flood sequence. We go down a little further, we go to the Morrison Formation, which is famous for its dinosaurs in Utah. Again, we find a volcanic ash bed, we extract the zircons, and we find there are fission tracks equal to 136 million years worth of nuclear decay at today's measured rate. Okay, I'm not saying there was 136 million years, I'm just saying if you use the assumption of today's measured rate and extrapolate back, that's the number you get. And again, if we go to the bottom of the Grand Canyon, the lowest of the units in the walls of the Grand Canyon, the Tapeats sandstone that we mentioned last night, it also has a volcanic ash bed in it, and the zircon crystals there have fission tracks equivalent to up to 500 million years worth of decay at today's measured rate. And that's at the bottom of the flood sequence. Now that makes sense. We know that therefore there's abundant evidence of nuclear decay during the time these rock layers were formed in the Grand Canyon, Colorado region, up to 500 million years worth. And it matches the supposed ages of these rocks. In other words, they're in the right relative order. But we know from our biblical foundations, our biblical time frame, that all of this occurred during the year of the flood. Therefore, we have observable physical evidence of 500 million years worth, measured at today's rates, of nuclear decay during the 1-year flood. In other words, the decay rate had to be grossly accelerated during the flood.